Hello everyone, I'm Angélica and I'm going to present our work named Crack Path Estimation in the short order 772 by a discrete element method. This presentation is organized as follows: Introduction, the lattice discrete element method, the LD, model description, results and conclusions. So the determination of the fracture toughness in quasi-brittle material is well defined, that proposes a consolidated procedure based on testing of pre-Fisher three-point bending specimen. As a matter of fact, fracture toughness would be overestimated by considering crack propagations under poor mode 1 loading. So during the fracture extension, cracks may deflect as a result of microstructural homogeneity inside the material. For example, in concrete, the aggregates, the fibers can represent this microstructural homogeneity. So Vantadori et al. Propose a modification of this procedure called the modified two-parameter model to take into account the influence of the shape and declivity with respect to the vertical direction of the main fissure that propagates from the pre-fissure during the test. The modified two-parameter model is used to compute the fracture toughness of quasi-brittle materials when a stable crack propagates under mixed mode loading, mode 1 together mode 2. So the tests are performed under three-point bending loading and the crack mouth open displacement control. Here we have the specimen geometry and the equations to obtain the fracture toughness using the modified two-parameter model. So the lattice discrete element method, the LD, consists of a set of masses joined by bar elements characterized by a regular cubic arrangement formed by 20 bars and 9 nodes. The bars are characterized by a bilinear constitutive law, which allows to take into account the reversible effects of crack nucleation and propagation. It is a law that considers the residual deformation when unloaded. In the LD, a random field is introduced for the fracture energy, and the fracture energy is modeled by a Weber probability distribution. So it's assumed that the material fracture energy may be appropriately modeled as a random field characterized by a linear space correlations defined by the three correlation lengths in the coordinate direction. The proposed methodology can be used to represent the inhomogeneity of the material. Here are the models simulated in the LD and the boundary conditions. So in the left side, we have the restriction in the X and Y direction, and in the right side, we have the restriction in the Y direction, and in the middle of the model is applied a prescribed displacement in the vertical direction. So the size of the cubic model used in the discretization is equal to millimeters, and here are the number of the models in the three coordinate directions. The material used in the experimental tests is the short earth, that is a material based on the shotcrete technology, a mix of soil, aggregates, and water, is consolidated by a high-speed projection. So, here are the properties obtained in the experimental test, for example, the Young model and the fracture toughness, using the modified two-parameter models, and these properties are used in the simulation. Here we present the results in terms of the rupture configuration, where the green region represents the region that bars not damaged, the orange region represents the region where the bar damaged, and the red represents the bars that broken. So, observe comparing the shape of the crack obtained in the simulation LD, we can observe that the shape is similar to obtained in the experimental test. Here we divide the model in three parts in the thickness direction, the parts A, B, and C, to observe the shape of the crack in these three parts. And we can observe that the LED is able to simulate the tortuosity of the crack like occurs in the experimental test. So the results obtained with the LED present a crack path similar to the experimental results. Thus, a discrete element approach can be a good tool to analyze the damage and fine rupture configuration in this kind of material. The LED is able to take into account the possible crack deflection during the stable crack propagation. And with the LED, it was possible to obtain the information about the stable crack propagation. In the next stage of this work, the results obtained by the LED will be used to complement the understanding of the modified parameter model. Thank you, and please, for any questions, contact me by mail.